Really having a wonderful time. There's so many great people that are here that we're working with. Uh, right here we have Russ Garcia. He is with Menlo Micro, and they have a really interesting set of contraptions. So tell us a little bit, Russ, about Menlo Micro and what brought you here to the AOC Summit.
Okay, well, I'll tell you about the ideal switch. What we have is a technology that was actually incubated and developed in GE research labs in Schenectady several years ago. That we spun this technology out. Bottom line is it's a switch that allows us to transfer energy in a much more efficient fashion than any other electromechanical device or even semiconductor device that's been developed before. And so it's really all um, about power handling and millimeter wave performance, which
Okay.
usually don't go together.
Well, that's an interesting statement right there. So, what do you mean they normally don't go together?
Okay, so at the end of the day, this is all about Ohm's law, and so we make a switch that has a contact that the basically ultra conductive, if you will, and subsequently we don't lose energy and heat. So in a millimeter wave application, what that does is that allows us to have really wide bands of operation. In a power or AC/DC power application, it allows us to switch and control energy, for example, in a solid state circuit breaker, without having to have heat sinks and the like. So subsequently, we get swap improvements of. So we're in a couple of systems. I can't name the systems, but we're in a couple of systems that are being designed, and now we're getting 50 to 75% improvements in weight um, and uh, and power usage, and because of the efficiency of the switch.
That is, yeah, it's pretty amazing, really, what you guys are doing. So, talk to us a little bit about some of the major applications that you guys are using this with.
Okay, so on the millimeter wave side, things like beam forming. So right now, accurate beam forming is a huge issue, and so our ability to have linearity, as I mentioned before, from DC to millimeter wave and very low insertion losses, allows us to make beam formers that subsequently don't use up a lot of power, um, and are very linear versus the transistors that are used today. So it allows those radar or comms applications to be much more efficient.
And just to key everybody in a little bit on that, but you're talking about radio and the background noise of a radio, right? Even
Right.
so you have a lot of background noise in a radio, and that is, of course, going to take more power in order to get the message across, and it's going to be harder for people to understand.
Right.
Where if you clean that out and you lower the background noise, and you don't.
Basically,
am I
that's
saying
it.
that right?
In
The
this
layman's terms.
application, it's actually being able to steer the energy from in a point-to-point situation where you want to they call beam forming in a phased array, that now you can direct the energy better. The ability to do this efficiently, where, for example, in a low Earth orbit application or a ground station application, allows those communications to happen with much less power, and so basically that's simple. So you get really super, large improvement in swap.
So here at AOC, obviously we had the Secretary of the Navy speaking this morning. A lot of military and government applications here. Are you guys looking at other ways to use it? Putting it out there?
So
for other
great,
people?
great question. So the next, or the really probably the biggest applications for this is in true power distribution and power control, whether that's a shipboard or airborne kind of situation, where if you can drastically change the weight and the energy usage on board a craft like that, you can change a whole kinds of, you can change mission lengths, for example, because you're using, if you dramatically change the batteries and the weight of the power distribution unit, you're using much less fuel. So whether it's it's a shipborne kind of application. You have longer range on a ship, or maybe even more importantly, in a fighter jet application.
Really cool. And then how about if we wanted to use something? I mean, in the future, do you think this will be available for different homes or
So I just had a couple of meetings about that today. Dual use, which is really an important deal right now, is being able to rapidly deploy a technology, especially a core component technology like this that ends up having a large system impact, but at the same time deploying those things commercially. So if you think of a power distribution unit that might be shipboard or aircraft or airborne, they're not a whole lot different than what you put on the side of a building from a how do I switch the power around. If I'm more efficient in that application as well, and control and distribution systems, whether they be microgrids, building management, EV networks, those are where also we're deploying these things in pretty much in parallel with what we're doing with the defense industry.
it's amazing. And I'll tell you, you're helping a lot, right? In a time when everybody's like green, 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 save, save, save. Well, here you go, and it's Menlo Micro. And who, how do people get a hold of you? How do they find you guys? If you'd like to some closing thoughts.
So menlomicro.com is our website, and of course you can get everything from there. Our headquarters is in Irvine, California. We have an R&D center in SUNY Nanotech in Albany, New York, and our new fab that we're building to onshore the technology is in Ithaca, New York, and we call that the Ideal Fab.
Amazing. Russ, thank you so much.
Thanks a lot. I appreciate it.
Appreciate it. See you soon.
All right.
Your voice is powerful. When combined with social engagement, it's a force for change. Decentralized media paired with free speech is the catalyst for an empowered world and a unified, invaluable ecosystem. Join Global Boost, become a champion of free speech, and help to reshape the future of media.